Today I'm going to solve LeetCode question number 143, reorder list. You're given the head of a singly linked list. The list can be represented as L0, L1, all the way to Ln-1. We just said the second to last element and then the last element Ln. Reorder the list be on the following form. L0, the very first element, Ln, very last element, L1, second element, Ln-1, second to last element, L2, the third element, third to last element, and so on. You may not modify the value in the list nodes, only the nodes themselves may be changed, so it means we can't replace the value of this, only the pointers here can be changed. Yeah, so let's look at the problem here. So in this case, we have the original form, L0, L1, L2, and L3, which is 1, 2, 3, 4. Okay, and then we modified it here to be L0, Ln, okay, very first, very last, and L1, Ln-1, which corresponds to 1, 4, 2, 3. Okay, so this is the very first element, very last element, second to last element. Okay, and over here it's kind of similarly, so we have like L1, L2, L3, L4, L5. Okay, so we have L1, or I guess I should start from 0, but that's okay, I'll make it 1 index for now. Okay, and then L5, L2, L4, and then L3. Okay, so notice how these are in order, in forward order, and these are in reverse order. So that's kind of the trick, that's the key thing to notice about this problem, about some elements are in the forward direction and some are in the backwards direction. Okay, so as we can see in this example here, it's all of these that are in the forward direction. I'll change the color. All of these are in the forward direction, and these are in the backwards direction. Okay, and then similarly for up here, these are in the backwards direction, these are in the forwards direction. Okay, so that's kind of the trick here. Instead of like doing some complicated kind of logic where we break this pointer, attach it to the very last, and then break this guy's pointer and then attach it to the second, and then break this guy's pointer, and then maybe we don't break it in this case, but then we break this guy's pointer to be the very last, as you can see here. Instead of doing that, what we can simply do is by noticing this property, okay, we're basically kind of halfway through the list, or almost halfway through the list, since this is odd, or a little over. Basically what we do is keep the first halves in regular sorted order, and have a second separate list for the latter half, and we reverse this latter half and then merge the lists together. Okay, so if I did that operation on this guy here, so we would have the first list 1, 2, 3, and then second list 4, 5, and then what we want to do is merge the lists. So I would merge it like that, like here. Okay, and then now this is the node in question, on focus, and then we merge it here. And then what we do now merge this here, okay, and then merge this one. Oh, sorry, I forgot to reverse the list. So yeah, that we have to reverse the latter half of the list. So 5, 4. Okay, let's do this again. So what we do now is first have that pointer here. Okay, now this is our focus node, and then what we want to do now is make that pointer 2. Now this is our focus node, and then have that pointer here, and then have this pointer here, and then this obviously points to none already. Okay, and that's how we're gonna go about that. This would be O of n linear time and O of 1 constant time, space complexity. And yeah, because all the space we need is a few pointers, and we're basically going to be splitting these lists in half, so we're not using any extra space here. So I guess it'd be O of n space. No, the result itself doesn't count. So it'd be O of 1 space. Okay, and that's how we're going to go about this. Okay, so now to code this up, first off we want to take care of a couple edge cases. So if head is none, or head.next is none. So if head is empty, if this is an empty linked list, or this linked list contains only one node, then we just return, okay, because there's no return type for this function. Okay, so now what we want to do now is split our list in half. So if our list is even, we want to split it here, and if our list is odd, we want to split it here, where the first list is greater than the second list. Okay, so what we want to do, how to split this list in half, is have two pointers, a fast pointer and a slow pointer, where the fast pointer goes 2 times the speed as the slow pointer. So by the time the fast pointer ends, the slow pointer is halfway down the list. Okay. So for example, for here, if we have a fast pointer and a slow pointer, they initially start at this head here. So fast would go twice the speed, skipping a node in between. So 1 iteration, 2 iteration, fast is none, so we can't go on any further. Okay. And then what would slow look like? 1 iteration, 2 iteration. Okay. So we're approximately halfway through the list. Slow pointer right now is at the beginning of our second list here, so that's great. And what about if this list is odd numbered? So fast and slow would initially start at this head, fast pointer 1 iteration, fast pointer second iteration. We can only do 2 iterations because if we try to do a third, we'll get an error saying the none value next has no next, so we can't do fast.next, not next. So we'll stop here, and then what would slow look like? 1 iteration, 2 iteration, okay? And basically the head of our second list would be slow.next, basically, okay? So split the list into 2, okay? Slow equals head, fast is equal to head, okay? And while fast does not equal none, and that's in the even case, or fast.next does not equal to none, that's in the odd case. slow is gonna be slow equals slow dot next, and fast equal to fast dot next dot next. Okay. Now that we have that, we actually want to break this list into two, and how we do that is remember when I said here, slow would end up, in the evening case, slow would end up being the head of our second list, okay? In our odd case, slow would be just one node behind the start of our second list, okay? So if fast, okay, if fast is equal to none, that means even linked list length. And what I want to do is list 1 equals head, list 2 equals none, list 1 is equal to head always. List 1 is going to be our forward direction, first half of the list. List 2 is going to be our second latter half of the list, which is going to be in reverse direction. Okay, fast is equal to none, then list 2 is going to be slow, else what we're going to do, and oh, one thing I forgot to mention is we need the previous slow pointer, which is basically going to lag behind our slow pointer by 1, and we're going to use that to actually break the pointer between the lists. So if slow is here, previous slow would be here, and then we would actually do previous slow is none. Okay, actually break it here, and here in this case slow would be here. So our new head would be here, and we would break this here. Okay. Okay. So now even length. So list 2 head is going to be slow, and previous slow dot next is going to be none. Okay. Else if it's an odd list length, where list 2 is gonna be slow dot next, and slow dot next is equal to none. Okay, remember in this case, so slow, we want our head to be up, or our second linked list to be here. So we do, the head is going to be here, list 2, and then we break this connection here by doing the slow dot next is none. Okay, and in this case, our slow would be here. So we have that to be a list 2 head, but we want to break this connection, so that's where we our previous pointer to have to make this line. Okay, actually break it. Okay, now that we split the list into 2, what we want to do is reverse second list, and how I'm going to do that is I'm going to have a helper function, which is actually going to reverse the linked list. Previous list 1, equal to head. So I'm going to go pretty fast through this because I already know how to reverse linked list. I hope you do too. And these two variables, this actually does the reverse, and then this sets up variables for the next iteration, and then previous is going to be the head of our newly reversed linked list. So okay, and now what we're going to do is weave our list together. Okay, how am I going to do that? Well, if we have our list like this, what I want to do is we have list 1 head here, list 2 head here. Is basically how are we going to know which list is, which node and which list is going to be a focus. So we're gonna, so that way we're going to update the next pointer to point to the previous list. So we can do that using I don't know, a variable. And if a variable is odd, then we're looking at the first list, and we're going to update its pointer, its next pointer, and if var is even, we're looking at the second list, and we're going to update its var pointer. Okay. So while list 1 does not equal none, and list 2 does not equal none, what we're going to do if var and 2 is not 0, if it's not even, then list 1, I'm going to do list 1, list 1 dot next, and update this guy's pointer here, dot next equal to list 2. Okay, so now this guy will be pointing to 4, and then we update this, and then now this is part of the weaved list, and now we focus on this guy for the next iteration. Else we do the same thing except with temp2 updating this pointer. And then finally we want to update variable for the next iteration. Okay, so if we go through the iteration the first time, the var is obviously odd, so temp is list1.next. This is temp list1.next is equal to list 2, so this guy's pointer will be pointed to 4 now, and now list 1's head is going to be updated to here. Okay, next iteration, from since variable is now 2 and even, we go through here. So 4 temp is equal to list2.next. This is temp, so list2.next 4.next is equal to 2 now, and now list2 equals temp. So now list2 is now going to go from 4 to 3. Okay, so we have 1, 4, 2 now, and 1, 4, 2. Yeah. And in the next iteration, we look at this guy now, and temp is going to be list1.next. Turns out not next is going to be none. Okay. And what we want to do is list1.next is list2, this is list2, and list1 is temp, so it's going to be here. And then next iteration, since list1 is none now, this loop is going to stop. And then we have our weave list of 1, 4, 2, 3. Okay. So let's give it a dry run. Oops, it just should be end. Well, fast is not none, and fast on next is not none. Okay, let's use see the other sample test case with the odd number of nodes in this linked list. Great, and I'll try submitting it. Okay, great. Thanks for watching.